Welcome to another video from OptaTube. Today, we're diving deep into green hydrogen. Now, you've probably heard it called the holy grail of clean energy, right? But behind that really promising title, there's a massive challenge brewing, an $11 trillion global race that is set to completely redefine industry as we know it. And this quote, well, it gets right to the heart of the problem. It's a brutal truth, a fundamental paradox baked into the laws of thermodynamics. So you have to ask, why on earth are governments and corporations pouring trillions of dollars into something that seems, on the surface, just fundamentally inefficient? That's the big question we're going to unpack today. So to really get the answer, first we have to break down why this paradox even exists. And spoiler alert, it's not some flaw in the technology. Nope, it's just part of the basic physics of the hydrogen molecule itself. Okay, this is absolutely the most crucial point to get. Hydrogen is not an energy source, like oil or wind is. You can't just go out and dig it up from the ground. It's an energy carrier. The best way to think of it is like a rechargeable battery, but in chemical form. We actually have to put energy in to create it so that we can then use that stored energy somewhere else or at a different time. And that whole manufacturing process, well, energetically speaking, it's pretty leaky. From the very first step, we're already losing energy. And the first and biggest hit comes from electrolysis. That's the process of using electricity to split water into hydrogen and oxygen. And the scale of that initial loss is, well, it's staggering. Even with the absolute best modern electrolyzers we have today, we lose about 30% of the electricity we started with just as waste heat. It's just gone. And that's before we've even thought about compressing, storing, or transporting a single molecule. Which, of course, brings us right back to the central mystery. If you're losing a third of your energy right out of the gate, why is this being hailed as the future? I mean, why would anyone design a system like this on purpose? Well, the answer is because hydrogen isn't actually meant to compete everywhere. It's designed for a very specific battlefield. A battlefield where our number one clean energy solution, batteries, simply can't fight. And that battlefield is heavy industry. Let's just be crystal clear about this. Hydrogen is not going to be powering your daily commute to work. That race is over. Battery electric vehicles have already won, hands down. Hydrogen has a much, much bigger job to decarbonize the massive energy-hungry sectors that are literally the backbone of our entire global economy. And this is where that big energy loss we talked about becomes a necessary evil, a trade-off we have to make. Take steel production. For every single ton of steel made with coal, we pump almost 2 tons of CO2 into the atmosphere. But if you swap that out and use green hydrogen as the fuel instead, the only thing that comes out is water vapor. For industries like this, there is just no other realistic path to get to zero emissions. And this isn't just some nice-to-have climate goal anymore. It's fast becoming a non-negotiable requirement for global trade. Policies like the EU's carbon tax basically mean that if your steel or your fertilizer is made with fossil fuels, it's going to get so expensive that nobody will buy it. Green hydrogen is turning into a ticket to just participate in the global economy. Okay, so if the need for hydrogen is definitely there, what about the means to make it happen? For years, hydrogen was kind of stuck in these small, symbolic pilot projects. But right now, we are finally seeing the technological and infrastructure breakthroughs that make a real hydrogen economy possible. The single biggest change is the mind-blowing scale of electrolyzer manufacturing. We're talking about a leap from tiny little demonstration plants to full-on gigawatt-level factories. And that scale? It's absolutely crushing production costs, making green hydrogen economically competitive for the first time in history. Keep an eye on the year 2026. It's looking like a major turning point. But here's the part that's a real game changer. These modern electrolyzers can act like grid sponges. You know when the wind is blowing like crazy or the sun is just blazing? Sometimes the grid has too much renewable power and has to just throw it away. They call it curtailment. Well, instead of wasting it, electrolyzers can soak up all that cheap surplus electricity and turn it into valuable hydrogen molecules. And there are two main technologies really driving this whole thing. You've got alkaline electrolyzers, which are kind of the mature, reliable workhorses. They're cheaper, but they take up more space. And then you have PEM electrolyzers, which are more compact and can ramp up faster, but they do rely on some pricey precious metals. Both are scaling up incredibly fast, which is creating a really competitive and innovative market. So the big question is, how do you move this stuff around? I mean, building a whole new pipeline system for hydrogen is a colossal undertaking. So the really smart strategy that's emerging is to build hydrogen hubs. The idea is you produce the green hydrogen right next to the industrial plants that are going to use it, like a steel mill, a fertilizer factory, or a port. This neatly bypasses that massive transportation headache.
All right, so all of these shifts in technology, in industry, they're all setting the stage for something much, much bigger, a completely new era of energy geopolitics. We are witnessing an $11 trillion race to control the next great global energy market.
And what I find totally fascinating is that the recipe for a hydrogen superpower is completely different from the recipe for an oil superpower. It's not about what's buried under the ground anymore. Now, it's all about having cheap sun and wind, huge open spaces of land, and stable access to big money and modern ports. This is literally redrawing the global energy map right before our eyes. Countries like Australia, Chile, and Morocco, places with just incredible renewable resources, they're positioned to become the new energy giants. And even traditional oil states like Saudi Arabia are pivoting hard, using their endless sun and deep pockets to try and lead in green hydrogen. But the competition isn't just about who can make the most molecules, it's about who gets to write the rule book for everyone else. The US is throwing tax credits at the problem to speed up production. The EU is getting really strict about defining what green actually means. And China? China is using its raw manufacturing power to dominate the supply chain. Whoever controls the standards is going to control the trade. So let's circle all the way back to that paradox we started with. We can see it now not as a technical flaw, but as a clear strategic choice. We have two options. Option A, we accept some energy losses up front to finally clean up the hardest, dirtiest parts of our economy. Or option B, we cling to efficiency, but we stay locked into fossil fuels for all of our heavy industry. There really is no perfect third option here. And this is exactly why it matters to you, even if you never ever fill up a car with hydrogen. The outcome of this race determines the carbon footprint of the very materials that build our modern world. We're talking about the steel in our cities, the fertilizer that grows our food, and the fuel that powers the ships connecting our entire global economy. So in the end, the question we should be asking isn't, is hydrogen a perfect solution? Because, let's be real, it's not. The real question, the one that's driving this entire $11 trillion race, is this. Who has the right strategy, the best technology, and the sheer political will to scale this thing fast enough to secure their industrial future and to win? If you are interested in energy market and power system modeling and want more updates and insights about the global energy market, then make sure to follow the OptaTube channel. Thanks for watching.